So we're going to do a lesson on getting kids to do prime factorization. When I do a lesson, I like to start with, what is it that the kids already know? So as we're looking at this one, the words prime is going to be really important, right? So in order for them to really understand prime and to be able to use prime, they also have to know composite. And so, we're going to do a review of this because it's been a while since they've heard it, maybe even last year or 2 years ago since they've heard it. I think we're looking at like a seventh grade class here, sixth grade class, but we're gonna work with the words prime and composite. They've heard them before. It's going to be review, but this is where we're going to start this lesson. And then we're going to work our way into factorization. So the idea of what is factoring, why do we do it? What is, two is a factor, but what does factorization mean? And then we're going to get them into specifically doing prime factorization and being able to do that. And then where are we going to finish this? So that's kind of the idea. So we're coming in with this idea that they understand prime and composite, but we're reviewing it, and then we're going to work our way to a prime factorization. Okay, so let's begin. So if I want to get the kids to remember prime and composite, my favorite is to work with visuals, right? So how can I get them to do a visual? So here's going to be my first part. I am going to say that I have 8 squares, specifically squares, and I need to make a rectangle out of them. So what are all the different rectangles we can get? So they're at the boards, they're randomly grouped, right? So what are all the different rectangles they can make me with 8 squares? So we're going to focus on them giving me this one, right? So I've got an 8 by 1. We're going to look for this one, a 1 by 8. Then we've got a 2 by 4, and then we've got a 4 by 2. So walking around the room, watching the kids do this, getting them to look around at other ones and seeing what what other groups are coming up with. And here I have all of the possibilities. So we're going to talk real quick and we're going to say, okay, I think you have all of them. And we're going to talk about how they're different. That this one right here is different than this one right here. Because like if we were decorating your room, you would definitely look at those as being 2 different arrangements. Okay, so they've done this for 8. So now we're going to erase our boards. We're going to tell them, all right, you're going to split your entire board, split it into 8 parts. And this one is going to be for 1, this is for 2, 3, and 4. And so what these numbers are, telling the kids as I'm putting these on the board, what these numbers are the are how many squares you have, and I need you to make as many rectangles. So we just did it for 8, so we already know that one, right? We've got 1 and 8. We've got, or sorry, that was 8 and 1. Wow. Okay, and then we've got 1 and 8, and we've got 2 and 4, and we've got 4 and 2. So we already have that one. So let's get them for the rest of them. So they go to their boards, they're splitting them up, right? So then I'm just going to quickly put them in here so that we have something to talk about here. If you have a group done, whether they got it right or not, it'd be a good idea to send them around the room to see other people, see if they have the same thing as other people. This worked really well. It got them, so one of the groups missed one, so it got them to come back. All right. And so when we're all done, let me finish off here. I originally was going to do 1 through 12, but then realizing how much space this takes up, I think 1 through 8 was effective enough. And so now I'm going to do like a little mini consolidation, bring everybody to one board that has them all, and then talk about what we notice. And so, kids are going to notice that they have rectangles, right? So we have these rectangles here. This is not doing, so we have a rectangle here and here, right? They're going to notice that some of them have the rectangles, but then they also have different sized rectangles. This one has a square. This one has different sized rectangles. So we notice those. We notice this one just has the one square. And so then we're going to talk about the words prime and composites. So I'm going to talk about how the definition of prime is that you just have those rectangles. You just have the number on one side and one on the other, a 1 and a 3. This is prime. Now they've heard of prime and composite before, so have them help define it, and then you're going to apply it visually, right? So they're going to know that a prime number is where you can only multiply one in itself. So then you can look at, which ones are prime then. These ones, 5 is prime, 7 is prime, 2 is prime. You can talk about how one isn't prime or a composite because it only has the one thing there. And then the composite ones are the ones that have these extra ones, right? So the 4, 6, and 8 have all the extra ones. So those are composite. Okay, great. So I think we've defined prime and composite pretty well, but let's just check. So we're gonna clear all this, have them erase all their boards, and now get them to draw. It worked out to do a table, and I had to tell them that this wasn't an XY table. Like if you put a 2 here and a 3 here, that 2 and 3 have nothing to do with each other. It's just a list. It's a place to collect a list. Okay, so what I would like them to do at this point is make a list of all the primes and make a list of all the composites for 1 through 8. You know what? Let's have them start with 1 through 8, right? So they put 1 down, they put 2 and 4 and 3, and I got a little sidetracked there. 5 is down here. Here's what I noticed they'll do. They'll go 7, 9. They get to 8, by the way. So let's get rid of that 9. Okay, so they get to 8, right? Because I told them to do to 8. So then composite would be 6 and 8. And then I say, okay, why don't you go up to, let's go up to 20. Just keep on going, go up to 20. So then what I noticed was they started doing this. They put an odd and even list. It's adorable, right? So I don't really want to have an odd and even list. So, but I also don't want to give it away, right? So one of the things I told them was make sure you're not making an odd and even list. Make sure you're thinking about prime and composite, not odd and even. That helped a lot of them, that they then ended up moving that 9 over to the composite list. And then they continued with 15 correctly. 17 and 19 go over here. I'm running out of room, but we get the idea. So we have a nice prime and composite list. Okay, so once we feel good that they all really understand their composite and their prime, and now we need to get into that factorization, right? So I write the word across the board. So factorization. And I ask if they know factorization, if they know this word, right? So maybe someone says, well, I know that if we have 8, one of the factors is 2 because 2 goes into 8 evenly. I don't get a remainder. Awesome. But then what I tell them is the factorization actually is the collection of factors that when you multiply them together, you get 8. So 2 times 4 is a factorization of 8, because when I actually do this math, I actually get the 8. So even though 2 is a factor on its own, it's not the factorization. So then I ask them on their boards to come up with the factorization of 8, all the different factorizations they could get. So then because we emphasized that the 2 rectangles were different when they changed direction, they'll actually most likely give you this also, and then they'll give you 1 and 8, and then they'll give you 8 and 1. And so they're really focused on the idea that there's only 2 numbers that give you that. And so then I'm like, that you guys did really good. Could you come up with a factorization that has more than 2 numbers, not just 2 numbers? Can you do that? What's the most factors you can put together to give you 8? And so many of them came up with this on their board. And what was interesting is they also came up with like 4 times 1 times 1 times 1, right? And so then I had to tell them, okay, I don't want ones. What's the most factors you could come up with that don't involve ones? Because we could do the ones all day, so it's kind of like cheating. So let's just forget about the ones, and let's just do a factorization without the ones. All right, so then they decided that, this two collection was the most that they could get. So that was really good. But let's see, can we do that for the numbers 1 through 20? So wipe our boards down and let's do that for the numbers 1 through 20. All right, so we've got 1, not sure, 2, 3, 4, 5, 6, 7, 8. Okay, so what's interesting about this is, we'll get the 4 is 2 times 2, 6 is 2 times 3, 8, they come up with the 2 times 2 times 2, 9, 3 times 3. So far it's not really all that interesting, right? 10 was 2 times 5. 11, they leave blank because it's a 1, right? So that and they end up leaving the primes blank. And so then we talk about if it's prime, go ahead and do the 5 times 1, or because I said no ones, maybe we just do a 5. And that really emphasizes that prime part of it. So then 11 would just be 11. Now, what's interesting is watching this develop. Like, it's super cool watching the kids do this 12, right? So they do 4 times 3, and then I've seen kids do 6 times 2, right? And so then they kind of come up with this little list that they have. And then 3 times 2 times 2. And so there's all kinds of ways they go about this. And one thing that I really want to get them to is that factor tree idea, right? Because that helps so much with our organization. So what I did was I came up to the groups and I said, tell me about this. Where did this come from? And they're like, well, I knew I had 6 times 2. And 6, I could do 3 times 2. And so I said, so tell me you did this. And so I said, I'm just going to record your thinking. So you said 12 was 6 times 2. And then the 6 was 3 times 2. Right. And they seem to be pretty okay with that thinking. And I said, look at how nice this is now. Now everything at the end are going to be the things that make up that factorization. I said, why don't you try that? With 16 and see how that goes, right? So give them another one to try and get them to try that out. Here's what we didn't do though yet. I haven't used the word prime yet about the numbers they're coming up with. Again, the instruction was just come up with the most that you could possibly do. And so then when they're all done and they've got them all listed through 20, then I asked them in their groups to do a notice, what do you notice about all of these? And hopefully they're coming up with that all of these have, like when they're done, all these numbers are prime. So we can talk about that and what that means. Okay, so now I have a challenge. The other thing I did was, after talking about that prime thing, we're talking as a group now. And what did you guys notice? And they noticed that those are all prime. The other thing I did was to talk about this, and because I didn't get to all the groups. So talk about that as a group, as a big class. And then I said, okay, now go back and erase your boards. And I want you to do this tree factoring with the number 24. All right, so then we go back to the number 24. And so now I'm getting them to start looking at, how can they take a bigger number and do that? Okay, so once they've done 24, then I want them just to start practicing with all kinds of numbers that I give them. So we could do like a thin slicing and list them, but this goes pretty fast. So what I decided to do was at each whiteboard, I gave each whiteboard a number. So 120, 150. And so what I told them, I still did the banner thing, but I said, if when you're done with your number, you're going to do your number down here. But when you're done with that, go ahead and erase that and then steal a number from another board. So they could just look around the room and start stealing numbers from other boards. And so I just gave a whole list of numbers. And then I started asking them, could you write these using exponents? So if you have, the 3 2s and then a 3, could you put 2 to the third times 3? So start getting them to be a little more sophisticated with their writing. Yeah, and then just get them to get the list. So this took an hour, almost an hour, like 50 minutes to go through this whole process. The next thing I was going to do, if I had time, I had two ideas. So how could I progress them past this lesson, especially if you have a quick group that's running out of things to do. So there's a good open middle. I love to finish with open middle problem. So in the open middle, I give them these boxes and they can fill in these boxes with the numbers 0 through 9, but they can only use it once to make the greatest product possible. So that's one option. The other option is to start looking at 16 and 24, and what factors do they have in common, just in general, what factors they have in common. So the idea of looking at hopefully coming up with the greatest common factor, but to start with, what do they have in common, um, and then putting those prime factorizations together then to create the greatest common factor. All right, so then we need to finish with a mild, medium, and spicy. So doing our check your understanding problems at the very end, just to solidify the individual side of this. So I had them erase their boards, and while they did that, I put the mild, medium, and spicy up and said, okay, here they are. So if I have, so I'm coming up with ones that don't have a lot of breakdown, like maybe they break down into two numbers and then only one of those numbers can break down farther. I came up with a medium list that have more of that, more breakdown than just the one extra. Numbers get a little bit bigger, a little more interesting of a breakdown. And then I came up with some good ones that have a lot of breakdown. So I looked for ones that have lots of prime factors as they break that down. And then just ask them, it took really, I found doing this part takes about, 5-6 minutes. You don't have to spend a lot of time, but, just asking them, like Peter says, asking them, where would you start? Where are you going to start? And then emphasizing too that we don't stop there. We're starting there and then we're going to keep on going. All right, so that was probably one of my most favorite lessons to do lately. Just the fun progression and not completely obvious progression of where we were going to go.